All right, so in today's lesson, we're going to be looking at using the quadratic equation to solve quadratics here. So first, recall the quadratic equation is equal to x equals negative b plus or minus the square root of b squared minus 4ac, the entire expression divided by 2a. All right, so just to remind you here, this represents your a, this is your b, and this is your c. We're mimicking the standard form of a quadratic, which is ax squared plus bx plus c equals 0. So that's what we're grabbing here. So now when I go to my quadratic equation, this is going to be x equals negative b. So my b is equal to negative 7, so it'll be negative 7 plus or minus the square root of your b value squared minus 4ac. And again, that entire expression divided by 2a. Simplifying we get, and you can see here by simplifying I'm getting under the square root, I just got a 1, and the square root of that is 1. So this is plus or minus. How it works is you're going to say, first we have 7 plus 1 over 6, which is going to give me 8 over 6, or 7 minus 1 over 6, which is 6 over 6, which is 1 over 1. You want to always express everything in lowest terms, so I can change the 8 over 6. I can divide top and bottom by 2, in which case we get 4 over 3. So the two roots of this quadratic are 1 and 4 over 3. Notice that our roots came out to be rational numbers, so we actually could have factored this question originally using charting or decomposition, but again, like I was talking about, this focus is just using the quadratic equation. All right, let's take a look at another example. So in the next example here, again, you want to identify your a, b, and c values. So I have a is equal to 3, b is negative 1, and c is equal to negative 4. So now subbing this into the quadratic equation, we get the following. And again here, watch the double minus sign, negative 1 becomes positive 1. Calculating our discriminant, I got 49 this time. And then again, we go through our calculations using the plus or minus. Here I got 8 over 6, again, reducing that to 4/3, and then the other root was minus 1. So once again, another situation where this could have been solved using decomposition or charting to find these roots as well. All right, let's take a look at another example. In the next example here, things are a little bit more messy. We've got a value of root 2, b value of negative 2, and a c value of 2 root 2. If you want, what you can do, because this is set equal to 0, one technique we can do is, since my quadratic equation involves the a and c, I'm going to have to kind of incorporate these root 2's into my answer. If you want to simplify this, make it look a little bit nicer, you can go ahead and multiply across by root 2. If I multiply across by root 2, this becomes 2x squared minus 2 root 2x plus 2 times 2 is 0, in which case we get 2x squared minus 2 root 2x plus 4 is 0. And then you can see here we can go ahead and divide across by 2. I get x squared minus root 2x plus 2 is 0. So just a simplified expression version of our quadratic. Before you go to that quadratic equation, if you can clean up those numbers a bit, as long as it's equal to 0, which it is, that's the only way you can use the quadratic equation is by setting this equal to 0. You have the option of multiplying across by some value to simplify your quadratic, or dividing, which I did both in this case. So now I'm going to go to my quadratic equation here. Doing the quadratic equation we get, and right away here, as I go through my quadratic equation, I end up finding I get a negative sign under the square root, which again, that can be discovered directly just calculating your discriminant. We could have been able to find right away that we have complex roots in this case. This can still be answered. To handle complex roots, we have to just take a look at what is the root of negative 6 equal to. Well, the root of negative 6 is equal to the root of negative 1 times 6, which can be expressed as the root of 6 times the root of negative 1. And we know that the root of negative 1 is I. So we can replace this with root 2 plus or minus root 6i over 2. So the following quadratic has two complex roots, which visually what that means is that this quadratic does not cross the x-axis. So since the leading coefficient of this quadratic is positive, even if you reference the first one, I guess we should probably look at the first one here. If you just were to graph this quadratic, ignoring your equals to 0 sign, you'll notice the leading coefficient is positive. This opens upwards and does not cross the x-axis, hence giving us these complex roots. Let's take a look at another example. In the next example here, again, we want to solve this. I want to use the quadratic equation. So before you do that, you have to expand everything out and bring everything to one side. Doing so, we get. So expanding and bringing everything to one side, we have the following. I'm going to go ahead and use my quadratic equation, giving us. All right, using our quadratic equation, I get the following here. I end up getting the root of 97. That can't be decomposed any further, so this becomes our roots here, -1 plus or minus the root of 97 over 4. So this is an example where factoring techniques will not work. You needed your quadratic equation to get these two roots here. All right, let's look at another example. In the next example here, again, one technique is whenever you see fractions, you want to get rid of them. So in this case here, I'm going to go ahead and multiply across by 8, giving us. And you can see here we end up getting the following expression by multiplying across by 8, brought everything to one side. Before you go to that quadratic equation, because you're setting that equal to 0, look to see whether you can reduce this a bit. And I can go ahead and divide across by 2. Dividing across by 2, you end up getting 2x squared plus x minus 12 is 0. And you'll see here, this is the exact same quadratic as we had in the previous example. So your roots are going to be exactly the same, -1 plus or minus the root of 97 over 4, just as before. All right, let's take a look at another example. In the next example here, we've got the root of x plus 2x minus 3 is 0. So this question resembles a quadratic fairly closely. If we rearrange this as 2x plus root of x minus 3 is 0, and if I did a little substitution here, if I let t equal the root of x, now our quadratic would read 2t squared plus t minus 3 is 0. And we can solve for this here. So this technique is called substitution. Let's go ahead and use the quadratic equation to solve this. So my quadratic give me t equals. And you can see here, using the quadratic equation, subbing in, I end up getting the root of 25. So again, comes out to be a perfect square. We get nice irrational numbers. And the roots here for my quadratic with a variable of t is -3 over 2 and 1. So we're not done yet. Those are the answers to this question. But again, we're looking to solve for x. So what do we have here? So these values that we've solved for are for the variable t, but we want to solve for x. So I'm going to go ahead and we know that t equals, in this case, -3/2. But again, t was equal to the root of x. So I know the root of x is -3/2. And right away, we see there's no solution to this. The square root function is only defined, if you recall, your square root function looks as follows. And you can see here that your square root function has a range greater than or equal to 0. The square root function is never negative. So there's no way that we can find a solution to this equation. So in this situation here, there is no x value on this side of our equation. So there's no solution in this situation. On the other side, we found that t is equal to 1, in which case the root of x is 1. Squaring both sides, you get x is 1, and that is in fact a solution. So the answer is x is equal to 1. All right, let's look at another example. So in the next example here, again, we always want to get rid of fractions. So I'm going to multiply across by x cubed, giving me the following. So going ahead and multiplying across by x cubed, I'm getting the following expression. Simplifies it and bring everything to one side. Again, we have a quadratic here. I'm going to go right to the quadratic equation. Again, this can be factored quite easily using our charting or decomposition. But just to show you, the quadratic equation does give the roots as well. Using our quadratic, we get. So using the quadratic equation, we quickly find the roots are -3 and 1. It would have been a lot quicker if we just would have went right to factoring. And that's generally what you want to do. You first want to check your discriminant because you'd have to use it anyway. And if I would have calculated my discriminant, I would have found the discriminant came out to be 16. Since it is a perfect square and my b value is not an irrational number, I know that charting or decomposition would have worked. So you can quickly see here, this is a simple trinomial. Would have factored into, in this case, I need two numbers that multiply to be -3 and add to be 2, in which case that would have been 3 and -2. So the answers here would have been quickly found to be -3 and 1. Okay, this concludes today's lesson on using the quadratic equation.